Introduction. Mom, look! I made a new triangle by joining two identical right-angled triangles.
That's great, Nick. Did you observe the sides and angles of the new triangle?
Yes, Mom. Two sides and two angles are equal.
Wonderful. Now join two right-angled triangles to create a new triangle with all sides and all angles equal.
I have done that as well, Mom. In this lesson, you will learn about the triangle and its properties. Objectives. At the end of this lesson, you'll be able to define median and altitude of a triangle, state the exterior angle property of a triangle, explain the angle sum property of a triangle, establish a relationship between the lengths of the three sides of a triangle, discuss the properties of equilateral and isosceles triangles, explain the Pythagoras property of a right-angled triangle, altitudes and medians of triangle. A triangle is a three-sided polygon. It has three sides formed by three line segments, three angles each enclosed by two adjacent line segments, and three vertices, each the meeting point of two sides. A triangle also has medians and altitudes. Median. Median of a triangle is a line segment drawn from a vertex to the opposite side, bisecting it. In the figure, line segment PS is drawn from the vertex P to the opposite side, QR. It divides QR into two equal halves. Therefore, PS is a median from vertex P to the opposite side, QR. A triangle has three medians, one from each vertex. Let us draw the remaining two medians. We draw a line segment from Q to cut PR into two equal halves at point T. Therefore, QT is a median from vertex Q to the opposite side, PR. We draw one more line segment from R to cut QP into two equal halves at point U. Therefore, RU is a median from vertex R to the opposite side, QP. Altitude. Altitude of a triangle is a measure of the height of the triangle. It is a line segment perpendicular to the base of the triangle drawn from the opposite vertex. In the figure, line segment PS is a perpendicular drawn from the vertex P to the base QR. It intersects QR at right angles. Therefore, PS is the altitude of the triangle PQR with base QR. A triangle has three different altitudes corresponding to its three different vertices. Let us now take a look at the remaining altitudes. We draw a line segment from Q perpendicular to RP at point T. It intersects RP at right angles. Therefore, QT is the altitude of triangle QRP with base RP. We draw another line segment from R perpendicular to PQ at point U. It intersects PQ at right angles. Therefore, RU is the altitude of triangle RPQ with base PQ. Exterior angles of triangle. A triangle has three interior angles. It also has some exterior angles. Let us take a look at them now. An exterior angle of a triangle, as the name suggests, lies outside the triangle. Exterior angle is formed when we extend a vertex of a triangle. A triangle has six exterior angles corresponding to its three vertices. If we extend vertex E of triangle FDE, exterior angle FEG is formed. Similarly, when we extend the vertices D and F, exterior angles EDH and DFI are formed. The measure of an exterior angle of a triangle is equal to the sum of the measures of its interior opposite angles. In the figure, angle FEG is equal to the sum of angles FDE and DFE. Let us now prove the same. We draw a line segment EJ from point E such that EJ is parallel to DF. If we regard IE as a transversal intersecting the parallel lines DF and EJ, angle 1 is equal to angle 4, alternate angles. If we regard DG as a transversal intersecting the parallel lines DF and EJ, angle 2 is equal to angle 5, corresponding angles. From the two steps we get angle 1 plus angle 2 is equal to angle 4 plus angle 5. It means angle FEG is equal to angle DFE plus angle FDE. Therefore, an exterior angle of a triangle is the sum of its interior opposite angles. Similarly, exterior angle EDH is equal to angle DFE plus angle DEF, and exterior angle DFI is equal to angle FDE plus angle DEF. Self-assessment. Read the question carefully and select the correct answer. Properties of triangle. The three angles and sides of a triangle exhibit some special properties. Angle sum property. Sum of lengths of sides property. Let us now learn about them one by one. Angle sum property. Angle sum property of a triangle states that the sum of the measures of the three angles of a triangle is 180 degrees. In the figure, angle A plus angle B plus angle C is equal to 180 degrees. Let us now prove the angle sum property of a triangle. Extend angle BAC. Angle 4 is equal to angle 2 plus angle 3 by exterior angle property. Adding angle 1 to both sides, we get angle 1 plus angle 4 is equal to angle 1 plus angle 2 plus angle 3. Angle 1 plus angle 4 is equal to 180 degrees, linear pair. It means angle 1 plus angle 2 plus angle 3 is equal to 180 degrees. Therefore, the sum of the measures of the three angles of a triangle is 180 degrees. Sum of lengths of sides property. The sum of the lengths of any two sides of a triangle is always greater than the length of the third side. In other words, the difference between the lengths of any two sides of a triangle is always smaller than the length of the third side. Three line segments whose lengths do not satisfy this property cannot form a triangle. In the triangle LMN, LM is 5 cm long, MN is 4 cm long, and NL is 7 cm long. Let us first look at the sum of the lengths of two sides. LM plus MN is equal to 5 plus 4, which equals 9 cm, which is greater than NL, which equals 7 cm. MN plus NL is equal to 4 plus 7, which equals 11 cm, which is greater than LM, which is 5 cm. NL plus LM is equal to 7 plus 5, which equals 12 cm, which is greater than MN, which is 4 cm. Now let us look at the difference between the lengths of two sides. LM minus MN is equal to 5 minus 4, which equals 1 cm, which is smaller than NL, which is 7 cm. NL minus MN is equal to 7 minus 4, which equals 3 cm, which is smaller than LM, which is 5 cm. NL minus LM is equal to 7 minus 5, which equals 2 cm, which is smaller than MN, which is 4 cm. Triangle LMN satisfy the sum of lengths of sides property. Special triangles. The sides and angles of some special triangles have some distinct properties. These special triangles are equilateral triangle, isosceles triangle, right-angled triangle. Let us learn about them. Equilateral triangle. Equilateral triangle is a triangle whose three sides are equal to one another. In triangle RST, RS is equal to ST, which equals TR. In an equilateral triangle, the three angles are also equal. In triangle RST, angle RST is equal to angle STR, which equals angle TRS. Therefore, an equilateral triangle is also equiangular. Isosceles triangle. Isosceles triangle is a triangle whose 2 out of 3 sides are equal to one another. In triangle LMN, LM is equal to LN. In an isosceles triangle, angles opposite to equal sides are also equal. In triangle LMN, angle LMN is equal to angle LNM. Right-angled triangle. In a right-angled triangle, the longest side is opposite the right angle. It is known as the hypotenuse. The two sides which enclose the right angle between them are known as the legs of the right-angled triangle. According to Pythagoras' property discovered by a Greek philosopher by the name Pythagoras, sum of squares of lengths of two legs of a right-angled triangle is equal to the square of length of its hypotenuse. According to Pythagoras' property, in right-angled triangle PQR, PQ square plus QR square is equal to PR square. In triangle XYZ, it is given that XY square plus YZ square is equal to XZ square. Let us measure angle XYZ of the triangle, which is opposite to the hypotenuse XZ. Angle XYZ is equal to 90 degree. Therefore, XYZ is a right-angled triangle. Summary. Let us summarize what we have learned. Median of a triangle is a line segment drawn from a vertex to the opposite side bisecting it. Altitude of a triangle is the perpendicular drawn to the base of the triangle from the opposite vertex. Measure of an exterior angle of a triangle is equal to the sum of the measures of the interior opposite angles. The sum of the three angles of a triangle is 180 degree. All the three sides and angles of an equilateral triangle are equal. Two sides of an isosceles triangle are equal. The angles opposite to the equal sides are also equal. Sum of two sides of a triangle is always greater than the third side. Sum of squares of lengths of two legs of a right-angled triangle is equal to the square of the length of its hypotenuse.